A very good evening, guys, and yeah, we are live now. And as you know, like today, the ISI MStat results have arrived, and yeah, so we are really happy that our students did really well, and like who did live classes with us. So yeah, so I'm really happy today, and let's continue problem solving class. And Tishika, hi. So I will be clearing your doubt towards the end. Okay, so before that, I everyone is quite familiar with joint distribution because today we'll do some problem solving and I'll introduce some new concepts of joint distribution via problem solving. Okay, that's the approach we follow. And yep, so I'm really glad to say you should be a proud junior of your seniors from Cheenta. Okay, perfect. So coming back to the class today, let's start with a simple problem. I always prefer doing problems from like Blitzstein. It's a really beautiful problem. So let's try out this problem. And it's involves certain ideas. Yeah, you have to send your problem, whatever problem you have. Okay, Tishika has some problem. Okay, this is a problem you have, Tishika. An issue. Okay, this is another problem. Oh, you have sent two problems. Oh, perfect, perfect. Perfect. So okay, let's try out this problem. There are two doctors, Dr. Hibbert and Dr. Neek, and they're called upon to perform a series of N surgeries. Okay. So why I'm making you do this kind of law in the it's like kind of word problems is that I really want you to model this via probability and random variables. Okay. So that will make it really your concepts really be like really very deep. Okay, that's why I'm doing this kind of word problems so that you can understand and model it by real life scenarios. Okay, the real life probabilistic issues that people usually face. Okay, so there are two doctors and they are called upon to perform a series of N surgeries. So let's H be the indicator random variable for Dr. Hibbert performing the surgeries, and suppose the expectation of H is equal to P. So what is the thing that it's telling that okay, so let's understand this. What is that? And given Dr. Hibbert is performing the surgery, is each surgery successful with probability A? Okay. And given that Dr. Nick is performing the surgeries, each surgery is successful with probability B independently. So let's X be the number of surgeries. Okay. So this is the idea. So now understand this very carefully. Now understand this very carefully. Then how do we model this? So what exactly it's meaning? It's telling that there is a surgery happening and there are two doctors. So the probability P is that Dr. Hibbert is performing the experiment, and probability 1 minus P is Dr. Nick is performing the experiment. That is what it's meaning. Okay, and given that Dr. Hibbert is performing, its surgery is successful with probability A. Successful, and like you can give a right and a cross with probability 1 minus A. Here also it's successful with probability B, and here it's not successful with probability 1 minus B. It's telling that X is the number of successful surgeries, is the number of successful surgeries. Okay, so let's try to model using H, using P, A, and B. Okay, we have to find out. So X is the number of successful surgeries. So what we will try to understand over here, guys? What we'll try to understand? What we'll try to model? So how I have taught you to model number of something? Bolo. How I have taught you to model number of something? Yeah, tell me. So how will you model this? So any ideas? So X is the number of successful surgeries. So how will you model X? How will you find X? Binomial model. You're correct. You're very correct. So for that we need to find the probability, right? For that, we need to find the probability. So how do we find that probability? How do we find that Bernoulli probability? Like, okay, okay, perfect. So to make it easier for you, we will introduce what is something called, like, we will use joint distribution. Okay, understand? We need to find the distribution of x. That's the final aim. So what we'll do, we will find a joint distribution of x and something. So we'll find joint distribution of x and h. So what is h? H is a bounded random variable, an integer random variable, which tells that whether Dr. Hibbert will perform in the surgery or not. H will perform the surgery. That's the integer random variable. H is that integer random variable. H is the integer random variable. It's telling that Dr. Hibbert is performing the surgery. And it's done with probability H. So with probability P. Okay. That's the basic idea. So H follows. What H follows? Can you tell me the random variable what H follows? That's the basic. Can you tell me the random variable what H follows? Bernoulli. Perfect. So H follows Bernoulli P. H follows Bernoulli P. ठीक है. Now let's take the first. Let's take the first surgery. Let's take the first surgery. Okay. Before taking the first surgery, we need to find joint distribution of x and h. Okay. So h follows this. We need to find the x ka. We don't know x ka individual distribution. We know h ka individual distribution, but we need to find something else. We need to find the joint distribution. Okay. And h and x are both discrete random variable right over here, right, guys? So we need to find therefore probability. What is the joint distribution? By joint distribution of random variables, we need to find out the whether what is the individual probability of the individual, like, joint density. We are not done the joint density, so we are doing the joint TMF now. So this is the idea, and we need to find probability x is equal to x and h is equal to 1. This is 1. And what are the possibilities? Is probability x is equal to x and h is equal to 0, right? These are all the two possibilities, right, guys? Did you understand? These are the only two possibilities. Yep. Like, the x is constant, h can be only 1 and 0. So if you draw x is what? X is the number of surgeries. So n surgeries are there. So x, the number of successful surgeries. X is the number of successful surgeries. So x can take values. So x can take values in 0, number of successful surgeries. So x can take values in 0, 1, 2, 3, or n. And h can only take values in 0 and 1. So we are trying to find out each individual of them. That's the PMF. For x, we are generally finding it out till n, such that this is 1. Okay, that's the basic idea. This is 1. So therefore, we will find out individual of this. So let's find out probability in a general case. Probability x is equal to small x. That's x number of successful surgeries are done, and h is equal to 1. H is equal to 1. ठीक है. So Dr. Nick or Dr. Hibbert are randomly given to do the surgeries, randomly called to do the surgeries, and each one of them is doing like all the surgeries. Okay. So it's like H is there. Okay. So what we know that given that Dr. Nick is performing the surgery, that is X is successful. So X is successful. X is the number of success. It's successful with probability A. Each surgery is successful with probability A, given Dr. Hibbert is doing that. So X given H1 follows what? Can someone tell me? X given H1, like X given the fact, the number of successful surgeries given the fact that H, like the Dr. Hibbert is performing them, what does X follow? Someone told that idea before, told that binomial. Binomial, you're right. Binomial, good. So given the fact that H is equal to 1, that is Dr. Hibbert is doing the experiment, X is following a Bernoulli n comma A. Perfect. And given that H is not following like Dr. Nick is doing, X is following binomial n comma B, right? That's given over here. It's very simple. Right, guys? All of you understood this? Any doubts? All of you understood this? Yeah? Anveshan, Mansi, Nikhil, Paulami, Pratik, Pratiksha, Promas, Riteja, Shuprabho, and Tishika. All of you understood this? Very good. So this is the basic understanding. This is why you're transforming the problem into a mathematical probabilistic problem. This is a very important step, and this is something you should follow. Okay. So the straight arrow is really important for you to understand what is really happening, to see the connection. So we have what? So therefore we need to find out the probability, this. And we know the information x given h is equal to 1. We know the distribution of that. We know the distribution of this. And we know the distribution of h. H follows Bernoulli P. So we'll use conditional probability over here. That probability x is equal to x given h is equal to 1 into probability h is equal to 1. That's a conditional probability, right? And we use the fact that x follows binomial. So this is what? N choose x, a to the power x into 1 minus a to the power n minus x into probability x is equal to 1, that is p, right? So therefore this one is turning out to be, and this one is turning out to be, let's check it out. It's turning out to be n choose x, a to the power x into 1 minus a whole to the power n minus x into p, right? And so this is turning out to be that n choose x b to the power x into 1 minus b whole to the power n minus x into 1 minus p. Okay? And this is all adding up. Did you understand, guys? Did you understand this? All of you understood this calculation using basic conditional probability. Did you understand how? Exactly. Yeah. Yeah, independently of also other surgeries, yeah. That's why we can do binomial because each one of them is a Bernoulli. Each surgery is a Bernoulli. Do you want to maybe break it up and let's make you see what is really happening? Huh? Do you want to bring me to break it up and make you see what's really happening individually? So each individual surgery are independent. So that's why we can sum all the surgeries up to make it follow binomial. That's a core condition to assume it's binomial. Otherwise, it will not happen. Okay. So we have got a joint distribution of p is equal to p x is equal to x and h comma 1. H is equal to 1. Very easy to understand. So this is the first step. Find the joint distribution of x. The next step is find the distribution of x. We have done this to do the x distribution of x. Find the distribution of x. Probability x is equal to x. We need to find it out. And we know that x is dependent upon h. X is known via h. So understand x is dependent upon h. So we need to find out this individual probability. So this individual probability is what? Probability x is equal to x is what? This plus this probability, right? So if you can write it, it's actually equal to probability x is equal to x given h is equal to 1 into probability is equal to 1 plus this is the lowest order probability. Given h is equal to 0 into probability h is equal to 0. And exactly that is sum of 2. This is exactly what the individual term is. Individual each one of them. Because this is equal to probability x is equal to h is equal to 1 plus probability x is equal to x and h is equal to 0. So this is essentially equal to n choose x a to the power x into 1 minus a whole to the power x into p plus n choose x b to the power x into 1 minus b whole to the power n minus x into 1 minus p. So that's the basic of probability. That's the basic of probability x is equal to x. That's the beauty of it. Okay. That's the only idea. So we have found out a joint distribution of this, and using that we have found out the marginal. This is called a marginal. Okay, we have found out the individual x distribution. You can also find out the distribution of h. Probability h is equal to 1, but you know that probability h is equal to 1 is p. So you know the distribution. So there is no individual distribution. This is equal to p. This is equal to 1 minus p. This is equal to p, and we have found out this individual distribution, which sum up to be 1. Can you show why it sum up to be 1? It's very easy to see. You sum it up over x, and it's very easy to see. Because you can understand, if you sum it up over this, if you sum it up on this side, you will get 1 minus p. If you sum it up over this side, you get p. So sum it up, finally it will get 1. So all is just equal, like everything is just mathematically very, very closed and very like deduced. Okay, perfectly closed. So if you understood this, how do we find out the marginal distribution and the joint distribution? We will do the detailed theory of that next Monday, but I'm just making you solve problems because you know the basics of it. All of you understood this? Any doubts? Good. Good. Superb. Superb. Okay. There's one question left. So usually with all these questions, we do x given, like we do the marginal with the condition and we do the posterior. So now if the question is very asking is that what is the probability that the doctor Hibbert has performed the experiment given that the number of successful surgeries is k. So it's asking the reverse. It's asking for the distribution of h given x is equal to k. X. It's asking for the reverse probability. Sorry, not inequality. This is actually done by Bayes theorem. So we have done this before. We have done this set of sums before. This is done by Bayes theorem. Okay, so how do you know it's Bayes theorem? Because first you define what is h. H is equal to 1, then h is equal to 0. This happens with probability p and 1 minus. Always draw tree diagrams. Okay, if you don't know how to draw tree diagrams, go back to the probability 1 videos in the recording, guys, and see those. Okay. And then out of this, there's success. That is successful. Like it's a binomial. Successful. So there are n such cases. So you get x. X is equal to 1, 0. X is equal to 1. Dot dot dot. Here also x is equal to 0. X is equal to 1. Like x given h. Okay, it's x given h. Okay. Similarly, this. So we need to find out this. That probability x h. That is, we are going backward from this. So here is x. Here is h. So we are going backward. But we have the information forward. We have information that x given h. That is, we have the information forward. We have h. So since we are going backward, that is the idea we have to use Bayes theorem. Okay. So because we have the information forward. So let's understand probability h is equal to 1, say, given x is equal to x. So we need to find this, right? So how to do this? We use Bayes theorem. So we just do the reverse stuff. X is equal to x given h is equal to 1 into probability h is equal to 1 by probability x is equal to x. That's the Bayes theorem, right? That's the first part of the Bayes theorem. Now you know this marginal distribution. You know this one and you know this one. All the things are you know, right? All the things you know. So you can find out the distribution. You know it's n choose x. Let's find out. It's n choose x. a to the power x into 1 minus a whole to the power n minus x into p plus n choose x into b to the power x into 1 minus b whole to the power n minus x into 1 minus p. And ऊपर क्या है? ऊपर this follows binomial, so it's n choose x, a to the power x, 1 minus a whole to the power n minus x, okay, into p. So you can cancel out this n choose x. Okay, that's one way of doing it, and you can find out the general result. So x is a constant over here. Similarly, you can do the other case also for the h is equal to 0. So it's very easy, and it's just basic applications of what exactly you have done till Bayes theorem in the first probability one. Just an application of that. Just the concept or application of that. That's why you will, as you progress more and more in our course, you will see, and as we learn more and more, you will see that everything is based upon our previous knowledge. That's why we have devoted so much time into your basic. Okay, so that we become confident in that footings of your understanding. Okay, that is super important. All of you understood this idea? All of you understood this? Any doubts? All of you understood this? Clear? Good. So here, Tishika has given a really good. Thank you, Mansi, for the boom. Thank you. So just basic. So remember, if your basic is really strong, you can ace anything. Okay, just remember that. Just remember that thing. Nothing more. Take it. Perfect. Okay, coming back to the next part, guys. Coming back to the next one. This is a doubt problem from Tishika. So let's see. It's an interesting problem. It's from a continuous distribution problem. So I think it's very important. So let's do this problem. It's a really interesting problem. So it's a distribution of one variable function. So let's see the problem. So yeah, you can actually make clear doubts with us. You have to send problems to me like this so that I can clear these doubts in live in the class. Okay, if you think that it's relevant for the whole batch. Perfect. So let's understand this problem. So it's given density, right? So given a density of the entire of a random variable, just find the distribution of y is equal to mod of x. Okay. So what is the first step, guys? Do you remember? Can anyone tell me what is the first step of finding a distribution? What is the first step? I told you repeatedly. What is the first step of finding the distribution? What is the problem solving strategy for the first step, guys? What is the first step? Anyone? Ha ha ha. No, what is the other method except the CDF method? Ha ha ha. Yeah, huh? But I didn't get you. Like, what is the other thing you're talking about? See, I want to ask you questions because. Ha ha ha. Yeah, exactly. That is the only method. Did I do any other method, Tishika and others? That one was for bijective functions. The other method was for bijective functions, right? And it was an application of the entire CDF. It's the application of the entire CDF, guys. A CDF for a method. So I don't remember, guys. This is a rule you must understand. My voice is breaking down. Okay. Yeah, actually, what happened is it's raining, so I think that's the cause of it. So I am trying. Okay. So I hope everything is fine now. You can hear me properly now. Okay. So yeah, the first step or the only step is the CDF method. Okay, only step is the CDF method, guys. Don't do any other method. The CDF method is that. CDF is the basic method. And the actual step when you're trying to understand random variable, the first thing is that you understand the CDF. That means you try to understand probability y less than or equal to small y. That's the first thing you try to understand. And you convert it into x because that's the information you have. So you have to find the probability capital Y less than or equal to small y. This is the thing you want to understand. Okay. And probability, you replace it with this because you have the information in terms of x. Just give me a minute, guys. Just give me a minute. Yeah. So I hope you can hear me properly. Yeah. Yeah. So we need to find in terms of x because that's the information we have, guys. We need to find in terms of x. And because we have the information and distribution of x here. So what we do is that we convert it into x. So remember this strategy, okay? This is very, very important. And we have probability x less than equal to y. So what is this? What does it mean? It means that probability x less than equal to y and less than equal to minus y, right? So we have the information in terms of x now. So it's probability. So therefore, this is what? This is capital X of y, the distribution of y minus this, the CDF of y minus this, right? Also, you can do it like in terms of this integration of minus y to y fx dx because that's the information you have. Now, the issue is that this is defined for different values. This is the only problem. It's defined for various values. Okay? This is defined for various values. So, kahan gaya? Everything is lost. Just give me a minute. Yes. So the idea is that here, so this is exactly a problem. So we need to find the integration here. It's now an integration problem, okay? It's not it's a so you're stuck in an integration problem, not a probability problem. I hope you can understand. You did till this point, right, Tishika? I hope you did till this point. Yeah, you can. You did it till this point. I know that. Yes. So the problem is that you are stuck with the integration, not the not the probabilistic aspect, because the probabilistic aspect is really easy. So yeah, so let's try it out. Let's understand how to do this integration. Okay, it's a math problem essentially. Integration problem. How to do this piecewise integration. That's it. How to do piecewise integration. So understand this was also the problem we was facing a problem in a few days and we are doing a similar problem. So understand now. If you put various values of y, let's put various values of y. If you put y is equal to, now before this, you find out what are the possible values of y, first step. Y can take values, y is mod of x is taking values from minus infinity to 3, right? So minus 1 to 3, right? X is taking values between minus 1 to 3, positive values, right? So therefore, y is taking values in 0 to 3, right? All of you understood this. X is taking values between minus 1 and 3. So y must be taking values between 0 and 3 because its y is equal to mod of x. All of you understood this point, guys? Yes. X is taking values between minus 1 and 3. So you are doing mod of x. So mod of x means what? Everything is becoming positive. So minus 1 से 0, वो 0 से 1 हो जाएगा. So minus 1 to 0 region, this will go to 0 to 1 region. And 0 to 3 region will go to 0 to 3 region under mod x, right? So y is equal to mod x will go to 0 to 3 region, उसका union. Did you understand? Minus 5 to, okay, 0 to 5. Because minus 5 to 0 will go to 0 to 5. 0 to 4 will go to 0 to 4. So उसकी union is 0 to 5. The range of y is that. The range of y is 0 to 3. Very good. So once you fix the range of y, this is a very important problem solving strategy, guys. Once the range of y is fixed, what you do is that you put values of y over here and check. Let's put value of 0 over here. Let's put value 0.1 over here. Let's put value 1.1 over here. Let's put value 1 here. Let's put value 1.5 here. All this. So if you put 0 over here, it doesn't matter. It's 0. If you put 0.1 here. So let's understand this. Okay, so you understood this. Let's put 0.1 here. So you put 0.1. So see, fx is defined piecewise, right? So it's between 0 minus 1 is minus 0.1 to minus 2 minus is minus 0.1 to 0.1. So that will be inside this region. So let's draw it. Let's draw this. Like the idea is that between minus 1 to 1, x is behaving something like this, and my 1 to 3, x is behaving something like this. Let's say I'm just assuming. I mean, it will be 0 actually. Something like this, something like this. So understand that you're taking what? You're taking around 0, right? Everything around 0, minus y to y. So if you take this till minus 1 to 1, it will be this function. If you take 0 0.1, 0 0.5, 0 0.3, it will be between this region. So understand, for y less than equal to 1 and greater than equal to 0, it will be what? Minus y to y fx dx. Now this will be what? For between 0 and 1. If y is between 0 and 1, that means it will be a part of this. So it will be actually equal to, if y is between 0 and 1, minus y to y mod x by 2 dx. All of you understood this? If y is the limit is between less than 1, then it is between this region, right? In this region. That means it will fx will follow this, right? Did you understand this simple idea, guys? This is super important. Did you understand this simple idea? This is everything clear? It's very super important, and that's why I'm telling you over again. Anyone who has a doubt, you can raise your hand. Sure, sure. Of course, I must. I know this is a problem. This should be the problem. Let's clear the flame. So understand how. So first step is that we decide the range of y. We understood that it's between 0 and 1, 0 and 3. Now understand this very carefully, that we're doing the integration between minus y to y fx dx. Now what is causing the problem? You understand what is, first understand the source of the problem you are facing. The source of the problem you are facing is this, that fx is defined differently in different region. So between minus 1 and 1, x is defined something. Between 1 and 1, x is defined in a different way. That's why I cannot take a uniform integration. I cannot put one single formula. So what I need to do? I have to break up therefore based. So what is this? So essentially this means what? You can write it as integration. Let's write it. Let's do a mental model. This means what? Fx belongs to minus y to y. You can write it also like this, right? Now understand, essentially like this, so not fx x. X belongs to this. This is exactly this integration, right? Now understand, fx is defined as mod x by 2 when x is between what? Minus 1 to 1. So if we take any y value, इसका value is between 0 and 1. So this, for any value of y between 0 and 1, this is a subset of minus 1 and 1. This value lies between minus 1 and 1. So therefore, during in this region for y between 1 and 0, this fx is actually mod x by 2. Did you understand this, Tishika? So therefore, integration of minus y to y fx is dx actually equal to integration minus y to y mod x by 2 dx if y belongs to 0 1, because then only y minus y to y will be a subset of minus 1 to 1. Then only fx will be this value. You need to understand why I am taking this value between this region. I am dividing this into parts so that fx ka we take certain values. This is the idea why I am dividing the integral depending on the value of y. So if this, then we can now you can find this easily. Let's see other one. What if y is greater than 1? If y is greater than 1 and less than 3, understand this very carefully now. This is another part. If y is greater than 1 and less than or equal to 3, what will happen now? Minus y to y kya hoga? Understand, minus, let's take 1.5. So minus y to y will be minus 1.5 to 1.5. But understand fx is defined from 1 to 3. So minus is not even there. Fx is defined between 1 to 3. So that means what? That means minus y between minus 1.5 to 1.5 actually equal to, so integration minus 1.5 to 1.5 fx dx is nothing but integration minus 1. Say fx is defined from minus 1, right? Minus 1 to 3. It's integration minus 1 to 3 fx dx, right? So understand minus y to y fx dx is same as minus 1 to y fx dx for y greater than or equal to 1, because if x cannot go below 1 minus 1, right? If y is equal to 1.5, it will be essentially minus 1 से, because minus 1 से 1.5 के अंदर कुछ नहीं है. If x is equal to 0. Did you understand this part? This is also another step. Did you understand this part? This mathematics part? Y is greater than or equal to 1 and less than or equal to 3. इसके लिए minus y to y कैसे, how will it look like? It will look like, let's say an example is minus 1.5 to 1.5. It will look like minus 2 to 2. ऐसे it will look. But fx is only defined on minus 1, x is only defined on, fx is only defined on minus 1 to 3. So we'll take the intersection part. Minus 2 to 2 intersection minus 1 to 3. That is the minor where it's defined. Here it's defined. And here it's the given like minus y to y integration range. So it's minus 1 to 2. So it will be minus 1 to y when y is greater than or equal to 1 and less than or equal to 3. Did you understand? All of you. Tishika, did you understand? It's okay if you don't, I will explain it again. Anvesha, are you sure? Mansi, Nikhil, Rajesh, Paulami, Pratik, Pratiksha, Proma, Sriteja, Shuprabho, and Tishika, all of you understood? All of you clear with this? Why this has happened? Clear? Sure. So let's say, let's take y. Okay. Let's take y is equal to 2. So you will get what? You need to do the integration minus 2 to 2 fx dx. Now understand fx is defined something between minus 1 and 1, and is defined something between 1 and 3, right? And 0 otherwise. So fx is not defined, so you can write it as this minus 1 to minus 2 to minus 1 fx dx. So in this region it's 0 actually, because it's not defined over here. So we write it as plus minus 1 to 2 fx dx. And it's not only for 2, it's actually for any y greater than 1. It's minus 1.1 के लिए भी होगा, because this region between minus 1 and that extra part will is 0. Did you understand? not in the support of x, where x is, I mean, it's actually in the limit, it's actually defined, but here it's 0. So that's why it's zeroing 0. You can write it as, you can write this actually, and you can write it 0. Okay, you can see where it's defined. You just change. Okay, you can also do it like this. So minus 2 to 2 say fx dx. You can write it in the range where it's defined. So it's minus 1 to 2. Minus 1 to minus 2 fx dx. This is one part. Another part is what? Minus 2 to minus 1, sorry. Another part is what? Minus 1 to 1. Another part where it's defined. Another part is what? Plus 1 to 2 fx dx. We are dividing because fx is behaving differently in different places. So here fx is 0. Here fx is mod x by 2 dx. And here fx is 3 minus x जो भी है. So therefore for y greater than equal to 1 less than equal to 3, it's turning out to be this. Now you have to divide it into two cases. Minus 1 to 1 fx dx plus 1 to y fx dx. And you have to find out in terms of y. All of you understood this? Everything clear, guys? All of you understood this? Why we are dividing this? So usually it's the integration problem that you're getting stuck in, not a probability problem. Okay, guys, everything clear? Write a boom in the comments if you understood this. Thank you. Perfect. Super. So everything clear, guys. So this is super important. The first step is from the CDF. The second, and this is actually one type of problem that you faced issue in. So this is one very important problem. Okay, so this is very good. Thank you for asking this doubt, Tishika. Perfect. Perfect. Okay, let's move on to the next problem, guys. Let's move on to the next problem. Let's move on to the next problem. So the next problem. Okay, let's see what Tishika has some doubt. Tishika's other doubt is marginal distribution of x and y. Okay, I will do this, Tishika. Okay, because I have not done this in my class yet, so I cannot do this now. Okay, but I will do this. Okay, let's do the next problem. Let's do some more joint variable problems so that you can become much more comfortable with joint variables. This is a really interesting problem. Let's do it. It's a very, I mean, it's a combinatorics mixed problem. So let's find this. So a committee of size k is chosen. Okay, a committee of size k is chosen from a group of n women and m men. Let's read this out. A committee of size n is chosen from a group of n women and m men. Okay, so just give me a minute. Perfect. A committee is done like that. What you're doing is the following: that you actually find a committee of size k is done, and you what you're doing is you're defining random variables. X the number of women and men on the committee. Okay, it's a random variable. So one thing, so understand that where is the probability part coming, guys? The probability part is coming in this aspect. The probability part is coming in this aspect that in this aspect that each committee size is equally likely. Each committee of size k is equally like. That's where the probabilities part is coming. Okay. So each committee size is equal, like understand, because you need to model this problem, so you need to understand each and every nitty-gritties of this. So each committee size is of this, of is equally probable. So it's very, 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 very important to understand this. So let's understand, let's really really crack it. Okay. So let's so we will find the joint PMF of X and Y. So it's be sure to specify the support. This is super important. So remember, when I was teaching you random variables initially, the first step was what? The first step was specifying, here in the previous case also, the first step was specifying what is the range of X and Y. So always remember that, otherwise you will not be focused. You will not know what is the value of X you're trying to find out. So what is the range of X and Y? What are the values? X and Y can take what? X and Y can take values 0, 1 to the dot, and Y can take values 0, 1 to the dot k, right? X and Y can be taking these values only, right, guys? All of you understood this? Ha ha ha. No, there is no given condition over here. If that was the case, then it would have started from what? Kya kya kya? Exactly. It is specified that at least one woman and at least one man will be there. Then the range would have been 1 to 1. You're totally correct. Perfect. Okay. So this is super important condition that you need to tell. You're right. Perfect. So what's next? The next part is this. So we need to find probability x is equal to x. This is what we need to find. Probability x is equal to x and y is equal to y. So we need to find this probability. So let's make a table. Always make a table. It will help you understand it geometrically. So if you make this table, you will see that x is taking values in 0, 1, 2, k, and y is taking values in 0, 1, 2, 3, k. Okay. Now there is one condition. There's a relationship between x and y. Can someone tell me what is the relationship between x and y? Can someone tell me what is the relationship between x and y? Can someone tell me what is the relationship between x and y? क्या? X and y are equally likely. What is x and y? Okay, but they have an intricate relationship, right? So x can be 100. Let's say k is equal to 100, and m equal to 200, and m equal to 200. Perfect. So this is a relationship between x and y. You're right. Okay, so x plus small y must be equal to k. That's the important relationship. So if it's 0, x is 0 over here, this cannot happen. Only possibility is this. Here. All else will be 0. What a possibility? Say it's k minus 1. If it's x is equal to 1, y must be equal to k. So the only possibility is here. Else are all 0. So you see, they will all lie in this line. That the sum is equal to x plus y. Here it's k minus 2, so it will be 2. All else will be 0. So all of the positive probabilities will lie in this line. And how many such cases are there? How many such cases are there? Can someone tell me? What will be the probability? Can someone tell me? What will be the individual probability of this boxes? Can someone tell me? It's very easy. What will be the individual probability of those boxes? Yeah, yeah, yeah. 1 by k plus 1. Why is that so? Perfect. So the k plus 1 cases, x is equal to 0, y is equal to k, x is equal to 1, y is equal to k minus 1, x is equal to 2, y is equal to k minus 2, karte karte, x is equal to k, y is equal to 0. So that's a k plus 1 cases. So 1 by k plus 1 and all of them 0. So how will you write this? So probability small x is equal to x and y is equal to y is equal to, you write it again by cases. If x plus y is equal to k, then it's 1 by k and 0 otherwise. All of you understood this, guys? All of you understood this? Perfect. All of you understood this? क्या 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 1 by k. Oh, हाँ, I'm so sorry. 1 by, thank you. 1 by k plus 1 होगा. You're right. 1 by k plus 1. Perfect. Everything clear with you guys? Any doubts? Now I have a challenging question for you. I hope everything clear with all of you. Anvesha, Mansi, Nikhil, Polami, Pratik, Pratiksha, Proma, Siteja, Shupro, and Dishika. Good. Now, next small question I have for you is that what if m and n are less than k? So let's do an example. Let's take an example, okay? Let's take m is equal to 10, n is equal to 6, and k equal to, let's say, 12. So what will be that? That will be a different case, right? Let's understand that then. In fact, what will be that is nothing but you will see. So let's do a 1 cross 12 one. 0 cross 0 1 to the dot 12 hoga, and here 0 1 to the dot 12 hoga. So what we exactly looking is that here let's say it's x, here it's a y. So from here it's y is possible from 0 to 6, and here it's 0 to 10. So essentially we are looking in this region, not the rest of the region. So we are focusing in this region. But we know that our line will lie on that x plus y is equal to 12 line only. That is this line. So it will be in this boxes that you see over here. So you just count how many such boxes are there. Okay. For six boxes are there, so that is one. Okay. And you have to count how many boxes are there. For 10, there are two. So you just count how many such boxes are there. Can you count how many such boxes, how many such cases will be there? Can you just count in this case? In this case, probability x is equal to small x and y is equal to small y is what? 1 by, how many such cases are there? Can someone count? How many such possible cases are there? It's very easy. 1 by 1 by 13. Let's check 1 by 13. Are you sure? Because 12 will not be there. Because m and n. No, x can take at most 10. No? That's the special case I'm doing. Counting. Hello? Hello, hello. Follow me, yeah? So see, here I am telling that here X can take till 10, okay? X can, like, there are 10 men and 6 women. So committee of 12 cannot have 12 men or 12 women, right? Even it can't have 7 men. So all the 12, all the 13 possibilities are not there. Did you understand? That's a special case. All the 13 possibilities are not there. So it cannot happen probability X is equal to, like, men is equal to 2 and Y is equal to 10, because Y can take only till there are 6. There are 6 women out there. So we have to restrict it. Did you understand? 1 by 10, why do you say it's 1 by 10? Why do you tell so it's 1 by 10? Yeah, so tell me tell me the X and Y for which it's possible. Tell me the first X. Tell me the first. Ha ha ha. Now I'm telling because X can take till 10 and Y can take till 6. So tell me the first X ka value for which it will be non, like, there will be existing such a committee. Tell me such an X and value and Y value for which there will be existing a committee. 6 comma 6 is the first one. This is the first one, right? And X is equal to 7 के लिए, then Y can be 5. And X is equal to 8 के लिए, Y will be 4. Still how much it will go? 10. So it will Y will be 2. उसके बाद नहीं जाएगा. So how many cases are there? 5 cases. This n minus n plus 1. Okay? That's the idea. So 1 by 5 cases in each one of them. So it's equal to 1 by 5 if X plus Y is equal to 12 and 0 otherwise. And X is less than equal to 10 and greater than equal to 0. All of you understood the variant of this. It's very important. The idea is perfect, but idea of this is perfect. Right? All of you understood this, guys? Any doubts? So, okay. So understand this. In this case, we are choosing a group of size. We're choosing a group of size K. So I'm choosing 12 over here. From a group of n women, let's say 6 women and 10 men. So if you're doing this, naturally, all the X, like the case 12 comma 1, 12 women and 0 men is not possible. All these are going out because there's at most 6 women can be there in the committee. So the only cases that where it's happening is 6 comma 0, 6 comma 6, that is told, 7 comma 5, 8 comma 4, 9 comma 3, 10 comma 2. I'm so sorry. Comma 6, 5 comma 7, 6 sorry 4 comma 8, 3 comma 9 and 2 comma 10. These are the only 5 possibilities that are there, right? Because it can hold at most 10 men and 6 women, right? All of you understood this. And a size of 12 must be chosen. Did you understand this, guys? So only 5 possibilities of committee are there. And rest are all 0. And all are equal, all the committee size of K are equally likely. So each one of them is 1 by 5. Did you understand, Nikhil? All of you understood? Anvesha, Mansi, Nikhil, Paulami, Pratik, Pratiksha, Proma, Sweetaja, Shuprabhati, Shika. All of you understood this properly? Any doubts? Perfect. Super. So let's move on to the next part. Next part says that find the so we have found a joint PMF. So next part specifies that find the marginal PMF of X in two different ways by computing using the joint PMF and using a story. Okay, so let's understand. Let's make a story first, so that and then we can calculate it. Okay. So what's the story? So we're gonna find the probability of marginal. Let's say just that's the marginal of men, women. Let's say the number of women is equal to sex. This is the probability we're trying to find out. So we know the probability in terms of committee size, right? And we also know that only one number of women is possible. If it's same as probability number of women is equal to X and number of men is equal to K minus X. This is the only case it's possible, and you can understand from the diagram. The sum are all 1, everything is 0. The sum is exactly this. Only one case is possible because the sum of the committee is fixed, and therefore it is equal to 1 by K plus 1 if X is less than equal to K and greater than equal to 0. Okay? Similarly for men. All of you understood this? All of you understood this? It's very easy. Once you fix the number of women, the number of men is fixed. Did you understand, guys? Yes? Well, I'm doing the general case, like this case. Not this case, but let's assuming that N and M are greater than K. We are doing that case. Yeah. Tell me what you didn't understand. No. Wait. So number of women, yes, fine. We want to find the probability the number of women in the committee or number of women in the committee is X. This is the probability I want to find, right? So once we want to find the number of women in the committee is X, that automatically fixes the number of men in the committee is K minus X, right? That means if number of women is equal to X, the number of implies automatically number of men is equal to K minus X, and so this is joint distribution. So it's equal to 1 by K plus 1. Because for only one number of women, like X number of women, there will be exactly K minus X number of men, right? Well, I'm not getting you. Can you come again? Okay. I mean, properly explained. I'm not able to get you, like where I am wrong. No, 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 no. Okay, I have done it wrong. Okay, okay, let me just think. Okay, this was also the part you didn't get wrong. Like you didn't get correct, Nikhil. I am sorry. Yeah, you're right. I have done it wrong. Yes, 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 yes. Oh, yes. I actually done it wrong. You know why? Can someone tell me why I have done wrong? Yes, I have done it wrong. Can someone tell me why I have done wrong? What assumption? Like I have done it wrong, so that's how you have to learn from it. So people have told me that I have done it correctly. So those who have told me I have done it correctly. So tell me now, like those who are telling me now that I have done it wrong. Yes, I have done it wrong. Now let's learn from it. That what I have done it wrong. What I assumed that I like the answer is coming out to be this. Can someone tell me? But I didn't get you. Come again. This is not assumed, but understand this. So what you're close. Suppose me like anyone who wants to explain where I have done wrong. There is no independence and independence. I have done it wrong in assuming that this is like all these are equal. That's fine. Can someone tell me? I assume that all these are equal, right? Probability. That is the place where I assumed wrong. Otherwise, the sum will be 1 by k plus 1. That's the place I assumed wrong. Why it's assumed wrong? Can someone tell me? So I assume that each one of them has equal probability. Can someone tell me why it's not equal probability? If I this question comes, that if I ask you this question, why this is not equal probable? Can you tell me? Anyone? Oh, tell me like why these two are different? Why these two are different probability? So the fundamental idea I assume that these two have the same so this is totally wrong. The fundamental thing I assume wrong is that these two have same probability. Why? Because I have sort of thought that each one of them is a committee. But each one of them is not a committee. Each one of them is collection of committees. Each one of them is not a committee. Each one of them is a collection of committee. Why? Because the woman and the man are different. So the probability I have done it wrong, the way that I have done it wrong is that probability that x is equal to k and y is equal to 0. This is no actually what that means probability that you have chosen men, k woman and 0 men. That means what? That means you have to now choose among the women now. That is m choose k into n choose 0 by the total number of committee that can be possible. That is m plus n choose k. You're right. It's hypergeometric. Thank you. So probability therefore x is equal to a small x and y is equal to k minus x is nothing but n choose x into m choose k minus x by n plus m choose k. It's hypergeometric. You're right. Thank you so much. Thank you, Polomi and Nikhil, for correcting me. Always correct me. I can do wrong. And that's where you win. Like you gain the confidence that like I have been wrong. Also understood it. Why I was making a mistake? I was making a mistake in this aspect that I assume each one of them is individually equally probable. Why? Because each one of them I thought as a single committee. But each one of them is not a single committee, each one is a collection of committees. Because the committees consist of different men and different women. Although its a size is same, the number of men is X. The committees are different. The committees are different. All of you understood it. Actually, I try to do this from the basic scratch. So that's why I made a mistake. But you did it in a perfect way. You connected it to what you know. That's the perfect way. Okay. So, but all of you understood it now. Did you understand where I made a mistake? Anvesham, Nancy, Nikhil, Paulami, Pratik, Pratiksha, Proma, Sriteja, Shuprabhoti, Shika. All of you told me that you understood when I did 1 by k plus 1. I will be more happy if you correct me. Did you understand, guys? Say yes or no, like anything, like so that I can understand your perspective. Yeah? You didn't understand? Hello? Why I'm not getting your messages? Oh, I only got Nikhil's message. Perfect. So always correct me, guys. It's very important to correct me. Perfect. So we have got this. Super, super, very good. So we have got this. Nice. You? That's it. Zero otherwise. Now you can do easily the probability x is equal to. Now let's do the story version. You can always calculate it, but let's do a story version and in the class. The story version is this, that you are selecting X women in the committee. That's what What's the probability of selecting X women in the committee? Probability of selecting X women in the committee is same as probability of selecting X women in the committee and K minus men in the committee, K minus X men in the committee. So it's therefore same as M choose X into N choose K minus X by M plus N choose K. So this was the next step. ठीक है? Oh, this must be equal to. This is the main idea, right? And that's the story version. We are choosing X woman, and that's same as choosing X woman and K minus. The joint PMS is not same. Why it's same? You have to understand this. Understand from the picture that once you fix this, automatically this is fixed. Rest are zero. You understand? That's why when you take this row or any column, there's only one value that is summing up. That's exactly this one. Did you understand?
Yes.
When you sum up this, is only all are zero and only this one is there. Since for one X there is only one Y that will make this committee, otherwise not. The number, I mean. The joint and the marginal is same with that same value here. That's it. It can be same. All of you understood it, guys? It's like it was clear already. Yeah, all of you understood it. So your homework is to find the conditional, the reverse one, or find a conditional PMF of y given x. Find this out. क्या 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 क्या? Given x is equal to x, what is it? You have to find probability y is equal to k and y is equal to some y. But there is only one y possible, that is k minus x. Rest will be zero. So find it out, calculate it, and share it in the group. Okay, let me just skip the problem. I told that probability y, you need to find this, right? Now you know that if x is equal to x, since y is equal to x minus k, sorry, k minus x, y is equal to k minus x, right? So it's same as probability. So this will be equal to this will be equal to 1 if y is equal to k minus x, 0 otherwise. Given x is equal to x, there is only one possible value of y that can make the committee, that is k minus x. Others will be 0. Given x, that you know that number of women in the group is, in the committee is x. Now you're trying to find the probability of the number of men. There's only one possibility of number of men, that is y minus x minus k minus x. Nikhil, is it clear? Is it correct? All of you, is it clear with you? Polam, is it clear with you? Sriteja, Mansi, Anvesha, Pratik, Pratiksha, Promas, Tishika, Shuprabho. Polam, it's clear? Huh? Good. Okay, thank you guys, and perfect. Good. So I will see you on Monday with more exciting joint distribution theory and problems. Good night, guys, and have a great night ahead. Bye bye.